Yesterday when we started the little flip book, we were looking at this top left corner and it said, determine the angles and sides from the given picture. If I say to you that these two triangles are similar to each other, then you can find the given angles by matching the corresponding ones together, because the angles will be congruent. You can find the proportional sides by either looking at the triangle and labeling it. Watch this technique. Labeling it as small, medium, or large, and then coming over here, small, medium, large. And that would let you compare small to small, medium, medium, large, large, which is the way I recommend it when I turn you loose with these practice problems. So where it says, give me the proportional sides, let's look at it. So like BC is the small side here. This is going to get crowded, by the way, so don't write really big. So BC, the small side over here is what, y'all? HF. All right, let's do the medium to medium. Medium in the big is what letters?
Medium and big?
Yeah.
What
are the letters of the side that measures the medium length in the big triangle?
H, G, and GF.
Big triangle.
Oh, sorry. A, C, and CB. Wait, no.
Okay.
A, B, A, C. A, B, A, C.
Why do you keep saying AC?
I'm lost. AB.
Yeah, because that's the medium and the large.
AB. I just want the medium.
Oh, I thought you said medium for the large.
Medium of the large.
Medium in the large. I'm sorry.
Oh, okay.
Sorry, maybe I should rephrase it. In that big triangle, name the side that has the M next to it. AB. That means it's the medium length, right? Now in the little triangle, what side is the medium length? GH. And now we're going to compare the long side to the long side. So in the big triangle, the long side is AC. And in the little triangle, the long side is GF. So when you have two similar shapes, you can set up your proportions as long as you're consistent. I want you, wherever you have room, to make a note that this came from the big and this came from the small, and it was that way all the way across. Like the big triangle was in the top of every fraction, the small triangle was in the bottom of every fraction. Now we're going to move to the bottom left, which is what you already know. It says determine the scale factor. So if I throw two triangles at you and I say, hey, these triangles are similar, can you tell me the scale factor? We've already been practicing this. When you first look at it, it might be hard to know what side matches to which, but if you'll use the whole small, medium, large technique, then you can compare the correct sides. So this is 7.5, 6, and 9. So once again, this is my small, my medium, and large. Then I've got 4, 5, and 6. So here's small, medium, and large. If I say, what's the scale factor, you can pick any two sides, pick any two sides as long as they're the same type. So if you pick small from right here, then you have to pick small over here. You pick medium, you have to pick medium. You will not set it up. I'm going to go, red means wrong. Don't write this down either. But you do not want to set up small to, say, large. Because if you do that, you're going to get the wrong answer. Okay? It says, since blank, then the scale factor is. So triangle ABC is similar. Remember, this is the way you write similar to triangle Did we say it was GHF?
Something like that.
Yes. GHF, we named it yesterday. Since those two triangles are similar, we can find our scale factor. I'm going to do just small to small because the numbers are smaller. Notice it doesn't tell me if it's a dilation to get bigger or smaller, right? It just says find the scale factor. So this means they just want you to compare the two numbers. So the small here is 6, and the small on the other side is what? 4. Now you do need to reduce it. 6 to 4 reduces to what? 3 to 2.
Could put it in the fraction.
You want to leave it as it right now, just a comparison of numbers, because they didn't tell us if it's getting bigger or small. They didn't tell us what direction to look at it. If I knew the direction, then I could tell you, then I would say, yeah, make it a fraction. By the way, if you have forgotten how to reduce numbers in your calculator, I'm going to make a note right here. You would go to your calculator, you would type 6 divide 4, and then you would hit math, frac, and it will reduce it. It will keep it as a fraction, but if I ask you just to write the numbers in general, you all right?
Yeah.
You're zoning out. It will spit the numbers out for you. Okay, what if I threw two triangles at you and I said, hey, can you tell me if they're similar or not? Like these two problems here was when I already told you they were similar. This is, can you tell me if they are? So if I throw that at you and say, decide if they're similar or not, you have two things to check. You have to make sure that the angles check out, as in like angle A is congruent to angle G. Angle B clearly by default must be equal to angle H because they're the only ones left. And angle C is congruent to angle F. So the congruent angles check out. And if you check, it says right here, congruent angles. You would say, yes, they all checked out. If you need to make your little list, you can. You can say angle A is congruent to angle G. Angle C is congruent to angle F. And angle B is congruent to angle H. Then it's going to say, are the sides proportional? So you know how we said right here the scale factor is 3 to 2? So basically what you would do is repeat what we did right here, but with the medium and the large, and you would just confirm that they all come to 3 to 2. So let me show you. Let me get my calculator pulled up. Okay, I'm going to actually use the one down here since it's already labeled small, medium, large. Okay, so just go in the same order. So I'm going to do small from the left, it's 6, divided by small from the right, that's 4. And I'm going to leave it. Now I'm going to repeat medium from the left, which is 7.5, divided by medium from the right. Leave it. So far, so good. You see the numbers are matching? Repeat, 9 from the left, large from the left, which is 9, divided by large from the right, which is 6. So all 3 of them check out. I compared small, small, medium, medium, large, large in the same order, and I got the exact same number, which means, are the sides proportional? Yes. So you can say triangle ABC is similar to triangle GHF. So when you're checking for similarity between the shapes, you've got to check the corresponding angles, then you've got to check the sides. Okay? picture's changed, different lengths, and this time we have an unknown value. So here's another approach with similar shapes. You can find the missing side length of one of them by using a proportion. So right here it says triangle ABC is similar. We already know that it's triangle GHF. They just changed the numbers. It's the same correspondence. So we can set up a proportion. So this is where, again, it's helpful if you look at your links. If I'm trying to find X, see right here, X, I have to find it. What side does X correspond with over here? So if you don't know it right off the top of your head, you can use the picture or you can use the similarity statement. The picture tells me it's between the double congruent angles and the blank one. So it would be right here. Double congruent angles in the blank one. Or you can look at the letters. It's FH, that would be the last two, so BC, the last two. Alright, so we're going to set it up. X compares to 9 as, and then now you're going to repeat. This next fraction has to be two numbers because we've already got a variable in here. So it doesn't matter which ones you pick. If you pick 5, for instance, that's GH. Come over here, GH matches with AB. So 5 compares to what? 10. And now you are back at what we did last week, solving a proportion. So how do you solve that? You just cross multiply. So to set it up, just make sure that you are consistent. When I say that, I mean that notice that the top two numbers, well, the letter and the number, they came from the same triangle. And then the bottom two numbers came from the same triangle. So we get 10x equals 45 divided by 10. And what do we get? 4.5.
I did different, but I like got the same thing.
So the nice thing about proportions and what we're about to do is there's actually 8 different ways you could go. And they're all correct. I have no way of showing all 8 ways every time because we'd be here forever. But yes, you could totally get a different proportion and still get the same answer. Okay, now I need you to open up your flipbook and we're going to look at each type of, I guess you could say, question or approach. So if you open it up, there's a lot going on. Let me see if I can make this actually bigger. A little bit, not bad. I'll just go with that. Okay. So if you open it up, let's focus our attention on the top left first. Now we don't have triangles. This time we have quadrilaterals. It says, tell me what the corresponding angles are and tell me what the proportional sides are. So, can you do that? Can you list it? Just like we did here, which I think this was angle A was congruent to angle G, we said, and then angle C was congruent to angle F. And by default, B would be congruent to angle H. That's what they're asking for. They want you to do that right here, but with that picture. So list it out, and then let's see if we get the same thing. So, do we have enough info to find D and Z? Yes, we do. Do you remember how many degrees are in every quadrilateral?
360.
Yay! Take those 3 and subtract them off 360, and you'll get the missing angle measure. And I think you find it to be 70. So angle A has to be congruent to what angle, y'all?
I'm sorry, angle A has to be congruent to angle Y.
Yes. Angle B is congruent to angle. Angle C is congruent to angle. And angles D is congruent to angle C. Now it's going to say list the proportional corresponding sides. So just start going around the shape. You can label, in this case, you have small and then you have two smalls and then a medium and a large. You could label it as that to help you. I always start with smalls and then I go to the mediums, then I go to the large. So for instance, if I was to go in alphabetical order, A, B, C, D, if I went that way, that put me going the medium number, a small number, then the large number, right? So I'm going to come over here and repeat that pattern. I'm going to find the medium number, which would be what, y'all? 14. Then I'm going to go the small number, and then I need to go the large number. Notice I went 105 to 85. So I need to do 105 to 85. So that would put me at labeling it Y, X, W, Z. Does that make sense? So it's a little off. It's not in the same order. So once I figure that out, now, and actually it's really crowded, so I'm going to take some of that off. That was bad. So can't draw straight lines on that tablet. So this is A, B, C, D. And then we said it would be Y, X, W, Z. That looks a lot better. So I'm going to write that right here, that I have shape A, B, C, D. And then right underneath it, I'm going to write Y, X, W, Z. So now I can set up my proportions because now my letters match. So AB is proportionate to YX, as the C is proportionate to XW, as CD is proportionate to WZ, and then don't forget the last to the first letter. So DA is proportionate to CY. Which, by the way, is, let's say, what's the length of AB? 7. And what's the length of YX? 14. What does 7 over 14 do?
1/2.
1/2. So all of these, if you go around and check, let's see, 5 over 10, does that go to 1/2?
2.
And then 8 over 16, 1/2. And then 5 over 10 again. So since the two shapes are similar, here's how you write it when it's not a triangle. You just write the letters out. Since the two shapes are similar, we can say that the scale factor is 1 to 2. Now Snap's lunch. I'm writing on the tablet, and it's sending the signal.
He makes $6 million a year.
6 million a year, I'm right, 5 to 10 million.
Don't stop talking about people that make more than me, and I have way more important job.
I think kicking in the NFL's pretty important.
Anyways, so before lunch, we were saying that these two shapes are similar, and we know that because we confirmed that the corresponding angles all pair up, and then we just checked all of the sides to see if they have the same scale factor. So now we're saying, okay, yep, they're similar. What's the scale factor? We don't really know if it's getting bigger or smaller. They don't show us like an arrow or tell us a direction to go. So when you don't know that, you can just write the two numbers side by side, and there's two right answers. You could write 1 to 2, or you could write 2 to 1. You could write either one of these, and you would have the right answer. Okay. Now let's look at these two right here. See this? Without having to write everything down, can you check all of the angles within those two shapes? First of all, what's the shape called? It's a pentagon. It has 5 sides. Can you check all of the angles off? Do they check off, or are there any left that are not congruent? They all check off. Now you have to check the sides. Now it's kind of hard to check the sides if you don't know the actual lengths of them, but if you see that this is congruent to this, to this, to this, to this, and then you come over here and you can see that you have the same congruent marks all the way around, then no matter what they measure, if I was to compare them, it would be the same scale factor. Does that make sense?
Yeah.
Okay. So I want you right here, I want you to label this shape, then label this shape, and write the similarity statement.
Hello.
Right here. So everybody do that. Label it right here. And then find the scale factor. You can't see? If you call this A, B, C, D, E, which I imagine is what you did, what would you call the next one? I'll be honest, it's really hard to know where to start on the next one because everything around it is the same, you know what I mean? So in this particular, I would not give you one like this, like in practice or on the test where there was some confusion. So in this particular case, I think it's safe to just start with what appears to be the top of the pentagon. Or you could go in alphabetical order. I'm not going to be nitpicky here. I dubbed A as like the top, and then I dubbed this as the top, and I went to the right here. So if this is upside down and to the right, it would go this way, right? You don't have to go that way because I would say this is slightly confusing in terms of that. But I'm going to call it Y, Z, V, W, X. Now the next part though you should be able to get, it says what's the scale factor? And you might be thinking, how am I supposed to answer that when there's not a single measurement? Look again closely.
4 to 3.
There are 2 sides labeled and it would be 4 to 3. There's a 4 here and there's a 3 here. And remember the congruent marks tell you, that that's 4 all around and 3 all around. All right, let's wrap this up. Look at the next one, top right section. Look at these. Let's see. I'm going to clear that. Oh, no, it's not. Okay. Oh, I know what I'm doing. Here we go. Watch, this is a lot of effort just to be able to blow this picture up, but I'm about to do it. Copy. Tab. And paste. And
Wow, look at you.
That seems pretty useless.
That's
do
that.
Yeah, I know. Why did you do that?
did that so that I can.
Golly, phone.
I did that so that I could see better. And y'all can see better. Yeah, I can see. Can you see?
No, it's kind of hard to see.
It's a little blurry, I'm not gonna lie.
That is really blurry.
All right. Anyways,
It's like my
let's
grandma's
look
word
at
searches.
the top two. The question here is: are they similar or not? Yes or no? So you've got, first of all, determine if they're the exact same shape. So they definitely both look like parallelograms. Then you need to check off the angles. Those are the easiest ones to check first. When you first look at the angles, what do you notice?
There's only one listed.
They're similar.
This says angle 75. There should be a degree symbol there. And then what's this?
Angle 105.
Okay. Oh, there it is. Do you remember this? This is 75
Vertical
degrees.
angle?
Not vertical. What do these little arrows mean on the sides?
Oh, parallel. So
Parallel.
It's some kind of transversal.
Yes, there is. Let me change
Linear
colors
pair.
and I'll show you.
So it'll be like you can slide down on that side.
There you
It's a
go.
linear pair. Huh?
So what would this have to be?
105.
There it is. Y'all ever heard that song? Ooh, there it is.
Yeah, I love that song.
That's from when I was growing up. Anyways, so this right here, because these are parallel lines cut by transversal, this would be 105 degrees because they have to add up to 180. I think it was called consecutive interior angles. Okay, and then now if you notice, if you go this direction, right? If this is 75, what's over here? 105. And then what's here? So this actually ended up working out nice, right?
Very nice.
Very nice. You writing it down?
I actually did.
Oh, okay.
You expected less from me?
Never.
You said that was such a disappointment.
So do the angles check out as that like each angle, the angles correspond and they're congruent? Yes, they do check out. Next is check the sides. Are the sides proportional? This is where you're looking to see if you type in your calculator one side divided by the other and leave it, do you get the same answer every time? Be careful though, these are turned in a different direction. So for instance, we've got 3 and 4, and then we've got 2 and 6. So clearly compare small to small. So if I do 3 divide 2 and leave it, now if I do 4 divide 6 and leave it, did I do that right?
That seems to be a problem because
That is a problem.
4 and 2 are both parallel, which means looks
No,
like
not
4.
necessarily. That doesn't matter.
It don't matter.
Yeah, they just didn't mark that these are parallel.
Well, then if they didn't work, they would have to.
Well, so look what just happened here though. Look what just happened. Look at my numbers.
It's like the
What do you
75.
notice? We got 1.5, but then all of a sudden now we've got 0.6 repeated. So when we set this up, are the sides proportional? The answer is no. And here's what we're going to show. This was the small, this was the large. There's no medium. This was the small, and this was the large, right? So when we compared small to small, and then large to large, we did not get the same number. Notice how I wrote that. So what's our similarity statement? That they're not similar. So here's an example of where it does not work out. The angles worked out, but what did not work out was the sides are not proportional. All right, let's move to this one right here. Here's another one of these where you have to be careful. Actually, this is the exact same from the other problem. So, are the angles congruent? Yes. And are the sides proportional? Yes. So they are similar, and we've already said that it's A, B, C, D. E must be similar to Y, Z, V, W, X. Actually, I like these. These are breath
So
professional.
this is
To me,
algebra.
the more challenging ones are the ones where it's yes or no. And the easier ones are where it's, hey, it's similar. Set up a proportion and solve. Oh, wait. I forgot. I cut it. All right, so let me.
It's crashed.
You make me feel so good about myself. What? I understand that.
That's why we're here.
Like I went to school, I picked a career, and I'm in the right place because of all the things
You are
you
in the
said.
right place, Miss Holcombe. You're the best teacher. Does that make you feel good?
It takes a refill.
Oh yeah.
She is pretty cool. But Miss Holcombe's so much cooler.
You're laying it on too thick now.
He was my second favorite teacher last year. Casey Dale Roberts first, you know him.
Did you say Del Wright? Is that his name?
Casey Dale Wright.
Is it Del Wright?
It's a Dale.
Dale, D-A-L-E.
Wait, you know Coach Dale?
All right, let's look at the last example, and then we'll turn loose on our practice, and I'll let you work with a partner. All right, so look right here. You with me?
She's like skinny.
Please look at this example.
Yes, Miss Holcombe.
The directions here are, hey, these two shapes are similar. I'm going to just draw this really big similar signal, notation, symbol, whatever. They are similar. And I'm asking you to solve for X and Y. Okay, there's a little bit of room here. Let's make a note. So since A, B, C, D is similar, now watch how I labeled it. I went 1 to 2 to 3 to none. So it would be W, X, Y, Z. Now we can set up a proportion. Let's solve for X. I always start with what I have to solve for. X minus 1 is proportionate to what side in the other shape? Very good. Then you draw your equal sign. Now you've got to have two sides that are just numbers because this is your variable right here. This is what you're trying to solve for. So you don't want to throw 3y plus 3 in here because
That's
then you're
times 3.
stuck. It's a plus, by the way. It's a plus. I know it doesn't look like it. You're never going to see the side of a shape labeled 3y times 3. You'll never see that. That's a plus sign right here, y'all. It looks really bad. Sorry. Anyways, so because we already have a variable x, that means we need to pick two sides where it's just numbers. They have to be consistent. X minus 1 came from this shape. So pick a number. Ooh, golly. I would pick 6. You knew exactly what you were doing, didn't you? Yeah, she did that on purpose.
She's a villain.
She did that. She
She's
said,
a
I'm just
villain.
going to go
She's
the
a
challenging route.
She's laughing.
I know, that's funny. All right.
I got you.
Yes, you can pick 7.5. I will not, because I prefer to pick regular, like non-decimal numbers if I can. You know what I mean? But if you pick 7.5, what do you by default have to put it over? You have to put it over a 5. I picked 6, which means mine goes over 4. All right, now we have exactly like last week. We're going to cross multiply that 4 to the front of the binomial. 7 times 6 is 42. And then you're going to distribute that 4. Don't forget the part that's after, in the back of the parentheses. Add 4 and divide by 4, and what do you get? 14?
No, it's a decimal. Maybe a decimal. It's gonna be like 11.
Oh, 11.5.
That in my head. I'm 2.
This times 11 would be 44. Now you're going to repeat to solve for y. This is 3y plus 3. So if I'm solving for y, I'm going to go ahead and use that so I don't forget what the goal is. What does 3y plus 3 compare to? 8. Very good. And then here's the beautiful thing about this. We don't have to reinvent the wheel here. We can take this exact fraction of numbers and copy it to right there and use it again, kind of like an anchor fraction that doesn't change if we're staying within the same problem. And once again, cross multiply. I love these problems because it's just basic algebra, and I always like the algebra problems. Told you. Not shabby, right? Why do you need glue? Oh, yeah. Yeah, throw glue out. Hold on. 48 minus 12. My pen is acting up. And then divide by 12. Come on. There you go.
Holcombe, have you ever had an encounter with a carrot?
Have I what?
Ever had an encounter with a carrot?
Yeah. I guess his name was more of a kin because he was a.
He was more of a Ben.
That's what, I think that's the,
But yeah, why?
what was it like? What happened?
I've had an encounter with parents.
Pause the report.
Yeah, I have too.
I'm in the mall running from the cops.